It's Wednesday, 7 November. My name's Juan Brown. You're watching the blancolirio channel. And by request, we're going to be discussing the Lion Air disaster in Indonesia, Lion Air Flight 610. We're also going to discuss the recently issued safety warning bulletin put out by Boeing aircraft regarding angle of attack sensors. Here's what we know about this disaster so far. On 29 October of this year, Lion Air 610 went down just 13 minutes after takeoff with 189 fatalities off the coast of the Java Sea. Weather at the time, it was 7:20 a.m. in the morning, which I assume was daylight. It was clear and light winds. The aircraft that went down was a brand new Boeing 737 MAX 8, which was just delivered to Lion Air on 13 August of this same year. It only had 800 hours total time since new. The crew consisted of 181 passengers and 8 crew members, and there's also been 1 fatality from 1 search diver. Shortly after takeoff on Flight 610, the pilots requested to turn back to the airport that they had just taken off from just 3 minutes after takeoff. At 8 minutes, radar data records the flight all the way down to 5,000 feet and 300 knots airspeed. Now normally, departing typically below 10,000 feet here in the United States, you maintain 250 knots below 10,000 feet or 250 knots in highly controlled airspace. These guys were already at 300 knots and 5,000 feet 8 minutes after takeoff. 10 minutes after takeoff, they were reported at 3,000 feet above the ground or above the sea. The last data point showed them at 2,500 feet, and an eyewitness report to the crash indicated they came down in a steep nose-down attitude. The pilots of Lion Air Flight 610 consisted of a captain with 7 years experience with the company and 6,000 hours flying time, and a co-pilot with 5,000 hours flying time. I don't know if that's their total flying time for their career or just the flying time with Lion Air. Shortly after the accident, the tech director for Lion Air was suspended. On 1 November, the flight data recorder was recovered in 105 feet of water, and they were able to recover 69 hours of data in the last 19 flights. I do not believe the cockpit voice recorder has yet been recovered. On just the previous flight, the previous day to this fatal flight, there was an anomaly with airspeed indications, and passengers reported a roller coaster ride while the pilot struggled to regain control of the aircraft. A pan was issued. That's just one step below a mayday call. The pilots initially requested to return to the airport. Then once they regained control of the situation, they decided to cancel the emergency and continue on to their destination. More on that later. On 6 November, Boeing and the FAA here in the United States issued a safety alert warning about angle of attack indicators and sensors. And it sounds like an emergency airworthiness directive is to follow shortly. And this is all based on information that they're already recovering from the flight data recorder. Just today, the National Transportation Safety Committee has confirmed issues with Flight 610's angle of attack indicators in the past, indicating they had problems with these AOA indicators on the last 4 flights. They replaced the AOA sensors, but the problem persisted, and they recorded a 20-degree difference between the pilot and co-pilot's angle of attack indicators. Lion Air is a low-cost Indonesian airline that's experienced explosive growth since it was established in just 1999. It's been blacklisted from the EU for nearly a decade for safety concerns, and in the last 16 years, Lion Air has suffered 14 accidents. I've been flying over 40 years, started out in small aircraft like this, soon got on with the Air Force, flew T-37s as an instructor pilot, C-141s, and then C-130s. Been on with a major airline here in the United States for the last 18 years, and because of the time that I got hired, I've managed to been able to experience the training in many different types of aircraft, including the Boeing 727, the 737-800, the 757, the 767. I'm currently first officer on the wide-body 777. I also got experience in the Airbus A320 series of aircraft and the old Super 80, MD-80. It was mostly my experience on the Airbus aircraft that really pointed me to the way of the future of the way modern, highly automated transportation aircraft are going to be designed in the future. Though I've never flown the new series of Boeing 737 aircraft, including the MAX 8, the last one I flew was the 737-800, it's a whole new generation of aircraft, but a lot of these additional safety features are now being built into the new Boeing aircraft that were once pioneered by Airbus. So what is an angle of attack indicator? Why is it that erroneous airspeed indications can become such a difficult problem to deal with in today's highly automated aircraft? Why is it that sometimes some of the protections that are built into these new highly automated aircraft become such a problem or can make a bad situation even worse when coupled with unreliable airspeed indications? There are a couple of trends going on in the aviation industry that have been going on for quite a while now. Experienced pilots are retiring and airline growth is booming around the world, so the experience level of airline pilots is decreasing. The design of aircraft is becoming more and more highly automated. Much more of the workload is being taken by the automation. It's when this automation fails, especially when coupled with an inexperienced crew member, that can lead to great problems very quickly. The Mighty Luscombe here is what I like to call the original fly-by-wire aircraft. You move the stick and a cable moves the flight controls. The pilot has 100% authority over the controls at all times. There is zero level of automation in the Luscombe. All the good handling characteristics are aerodynamically built into the design. Today's more modern aircraft, engineers are slowly writing the pilot somewhat more and more out of the equation as to how much flight control input he directly has on the aircraft at any given time. Nowadays, fly-by-wire literally means electronically or even with fiber optic cables, control inputs are fed into flight computer systems which take a mountain of data input, including angle of attack, airspeed, engine, pitch, power, put all that together and at the speed of light come out with a solution to apply to the flight control. Garbage in, garbage out, we've learned all that on our home computer. If the data input going into the flight computer, the flight control computer, the FCCs, is corrupted or erroneous, you will get numerous malfunctions in your new modern highly automated jets. So when I first transitioned to the Airbus, which was a whole new level of automation that I'd ever experienced on any of the previous Boeing aircraft I flew, the first thing I asked when I walked into the sim is, how do I turn all this automatic stuff off? Because on modern aircraft, even if you turn off the autopilot, you still do not have 100% control of that aircraft as a pilot. You are still only given a major portion of the vote of what control input goes in versus what control actuation happens. So it's imperative for crews to be able to recognize quickly unusual instrument indications and how to recognize them, get into a state that is safe, and get the automation properly turned off to fly the aircraft. To get the aircraft in a safe state, you still have to memorize, yes, memorize some basic pitch and power numbers that will recover the aircraft to straight and level flight for your altitude and configuration. In light of the Air France Flight 447 Airbus crash, unreliable airspeed indications have become an emphasis item for airline pilot training throughout the United States. All modern transportation aircraft, as has been the case for years, is built on the concept of redundancy. There are two completely independent sets of instruments between the pilot and the co-pilot. Each set of instruments is fed by completely independent sources. When one side goes wrong, the trick is to determine which side is the wrong side and which side is reading the correct information. This is particularly disorienting in night or IMC instrument conditions when you're flying in the clouds. This is a pitot tube. This measures the ram air pressure of the air impinging on the aircraft to give you your airspeed indication. In modern jet aircraft, of course, these are heated and there are multiple pitot tubes. This tiny little hole is the static port. It measures the static air pressure outside the aircraft to give a differential between the ram air pressure of the pitot tube and the static air pressure beside the aircraft to give you airspeed indications. One data input that the mighty Luscombe does not have, but all airliners have, is the angle of attack vane, or angle of attack indicator. The angle of attack vane is a small heated balanced vane mounted on the side of the aircraft, which measures the aircraft's angle of attack, the mean chord of the wing versus the relative wind. It's this difference between the mean chord of the wing and the angle of attack of the relative wind that makes up the angle of attack. Why is the angle of attack important? Basic aero review. Remember, an aircraft can stall at any indicated airspeed or at any attitude, but an aircraft can only stall at one critical angle of attack for a given configuration. That's why the angle of attack indicator is so accurate and so highly used by fighter aircraft, especially Navy aircraft flying onto aircraft carriers. They are flying the minimum angle of attack to maintain the maximum performance from their wing to obtain the short field landings that's required for carrier operations. Here's what these look like on the side of an airliner. 2 heated pitot tubes and 2 heated and balanced angle of attack vanes on the side of the aircraft, independent of each other. These are automatically heated to prevent freezing up while flying through freezing precipitation. On rare occasions, pitot tubes can become blocked. Static ports can become blocked. Maybe static ports were left plugged from a previous maintenance, a painting of the aircraft, for example. Angle of attack vanes can get jammed, stuck, or otherwise not work, or AOA sensors can fail. This is where the built-in protections of a modern jet can become a problem when the data input to the flight control computers becomes corrupted. In a modern, highly automated jet, protections are built into the flight computer systems to help prevent some of the basic, old-time pilot mistakes that have been made for years and years. Stalling the aircraft, flying too slow, that is, exceeding the critical angle of attack of your wing for a given configuration, and or overspeeding the aircraft, flying too fast. In the case of flying too slow, in today's highly automated jets, if the computers sense that the aircraft is coming up to or exceeding its critical angle of attack, it will automatically, even with the autopilot off, move the throttles to full throttle and push the nose over. It will give you an elevator down input. In the event of excessive airspeed where you're threatening to overspeed the aircraft for a given configuration, the automation will take over and automatically retard the throttles and induce a nose up input. So what happens when the data is corrupted? If your angle of attack indicator or sensors are putting wrong information into the computers can sense that you are in a stalled condition and thus jam the throttles full forward and give you elevator down inputs, even with the autopilot turned off. This is the point where you got to get the level of automation down to a state where you can control the aircraft. You need to know where those flight control computer shutoff switches are and get them shut off. You also need to set your memorized pitch and power settings that will get you safely away from the ground for your given configuration. So what does all this mean for Lion Air Flight 610? Well, it's a little too early to tell. If we can find the cockpit voice recorder, we'll be able to quickly determine how the pilots reacted to this situation and if they applied the proper standard operating procedure to recover from this situation. The fact that the previous flight experienced this anomaly, initiated a return to the airport, and then canceled the emergency and flew on is almost unconscionable here in the United States. This is such a high emphasis item and such a potentially dangerous item that there is going to be reports filled out until it equals the weight of the airplane. If you have such a situation like this here in the United States, you need to declare that emergency and get that aircraft back on the ground as safely as possible, quickly and safely as possible. You do not, under any circumstances, cancel the emergency and continue on to your destination. That does not look good for the Lion Air safety record. In the big scheme of things, what does all this automation mean? Well, this automation overall is doing a great job in reducing accidents and increasing aviation safety overall. Unusual airspeed indication problems are still an extremely rare event, but still need to be dealt with quickly and correctly by the air crews. Just as I was filming this, the new emergency airworthiness directive has already come out on the Boeing 737 MAX aircraft. And Boeing is having you treat this situation as a runaway trim or runaway stabilizer trim situation. In this situation, Boeing is calling the crews to cut out the elevator trim cutout switches, turn off the automatic application of nose down elevator trim in the event of an AOA or unreliable airspeed indication. And this is happening in manual flight. They've turned the autopilots off. The new 737 MAX aircraft, if sensing a low speed condition, will begin to trim the nose down of the aircraft in 10-second intervals to try and recover from this low speed situation. Apparently, if crews do not turn off the elevator trim, it will continue to trim nose down until it may very well reach a full nose down trimmed condition. That can be a very difficult situation to recover from, especially if you are at high speeds like at 300 knots. We'll continue to follow this mishap and emergency airworthiness AD and update you as necessary. See you here.